What if instead of using a sharper microscope, you could just make your sample bigger? We'll introduce you to a new technique that does just that this week on Light Matters. This is Light Matters for February 4th, 2015. I'm Justine Murphy.
And I'm James Lowe. On this week's show, we'll find out about how researchers are enlarging tissue samples and explore a new concept for image sensors.
We'll also tell you about the last group of finalists for the Prism Awards, which will be presented next week at Photonics West in San Francisco.
But first we mark the passing of a founding father of the photonics community. Dr. Charles Hard Townes, whose pioneering work on stimulated emission gave rise to the laser devices now so ubiquitous in science and society, died last week at age 99. Townes led a team of researchers who demonstrated the first microwave laser, or maser, in 1954. He went on to propose optical lasers 4 years later. These foundational contributions won him the Nobel Prize in Physics in 1964. Townes joined the faculty at the University of California, Berkeley in 1967, where he continued to use masers and lasers for astronomy until just last year. In addition to his academic work, Townes was also a prominent player in national science policy.
Photonics West starts next week, and a cornerstone event will be the presentation of the 2015 Prism Awards. Sponsored by Photonics Media and SPIE, the awards recognize innovative light-based technology products that solve problems and improve quality of life.
For the last 8 weeks, we've been telling you about each of the award categories and the finalists in each one. This week, we'll take a look at the 3 products competing in the 9th and final category, scientific lasers.
The WhiteLase SC400-20 from Fianium in England is a tunable supercontinuum fiber laser for flow cytometry, semiconductor metrology, fluorescence imaging, and lifetime spectroscopy.
Northrop Grumman's 7.5 joule diode pumped solid-state amplifier is used for petawatt and terawatt laser systems.
And the Intelligent Fiber Collimator Array from Optonicus of Ohio is a laser beam transceiver system for directed energy, remote sensing, communications, target tracking, and materials processing.
The award ceremony is next Wednesday night. Justine and I will be there, and the Photonics Media team will be at BIOS and Photonics West throughout the week.
We hope you'll come visit us at booth 523. You can sign up for free subscriptions to our magazines and even get your picture on a magazine cover. We'll see you in San Francisco.
Last week, Photonics Media hosted Dr. Eric Fossum of Dartmouth College for a webinar on next-generation image sensing. His quanta image sensor concept involves counting individual photons on sensors made of 1 billion or more sub-diffraction limit detectors called JOTs, which are read out at data rates of more than a terabit per second.
Once we collect this kind of fundamental binary information, photons are basically binary in nature, at least when they interact with silicon, and we basically do that sort of analog to digital conversion right up inside the JOTs in a way. Everything else after that is programmable, either by, well, could be in hardware and fixed, or it could be in firmware, or it could be later in software farther down the signal chain. It gives a great deal of flexibility in how to use that information.
You can watch a recording of Fossum's presentation at photonics.com/webinars. That's where you can also find out about upcoming free webinars and watch recordings of more than 40 past presentations.
Meanwhile, Photonics Media is seeking presenters for a digital conference on biophotonic imaging for medicine. The online event will be held June 11th. Interested researchers can submit abstracts on light sheet microscopy, optical coherence tomography, photoacoustics, computational imaging, and more at photonics.com/bioconference.
Standard confocal microscopes can't resolve anything smaller than about 250 nanometers, but now there's a way to enlarge biological tissue and make its nanoscale features visible. Expansion microscopy was developed by researchers at MIT using sodium polyacrylate, a superabsorbent chemical found in disposable diapers. The substance swells dramatically when it comes in contact with water. Injected into biological tissue, it can make cells and subcellular structures grow to as much as 4 times their normal size. Graduate students Paul Tilburg and Fei Chen explain why this is significant.
So the relative shape of the structures you want to look at stays the same, it's just bigger.
This is important because this means anyone out in the world can apply those steps to their sample and put it on the microscopes that they already own to make their microscopes into super resolution microscopes.
Expansion microscopy enables rapid imaging of nanoscale features across relatively large samples, giving the technique an advantage over super-resolution microscopy, which works best with small, thin samples. The research was published in Science.
That's it for this week's show.
We hope you'll tune in next Wednesday for a special edition of Light Matters, where we'll explore an exciting and unconventional new idea for the future of space telescopes. Orbiting rainbows would use clouds of glitter to see the universe in more detail than ever before.
And join us in 2 weeks for a special report from Photonics West. And be sure to visit us at booth 523 if you're going to the big show.